Hi, it's Gadget UK here again. Just doing the second part of the repair to this King of Monsters car. Just thought I'd show you a couple of things really. Things I should have done before I ordered the EEPROMs, but it was just easier at the time and stuff. Anyway, so as you can see, game's running at the moment with a crackly sound. There's the system. You can see actually I've not covered that yet, but I've got a 5 volt display there. So what I'm going to do is just check the data pins, because I was thinking about this. That's one of the first things I should have done really, just to determine which one of those, well, is it the chips, is that what it is? And a quick easy way of doing this for me with my scope is to just go, I'll show you, I've got the data sheet here for the, and this is a pin compatible chip, so it's not the exact same chip, and you can see this. I'm looking at this one here, the CDIP, PDIP top view. As you can see, on this side of the chip here, this side of the chip bottom left here, you've got all these O pins, which are data pins, and there are a few on the other side as well. But I thought I'll just start by counting down to pin 12, which is ground, and then on the scope, let's just check what's coming out of 13, 14, 15, all the way down to 21, because they're all, 13, 14, all the way down to 21, because they're all the data, where the data bus connects to effectively. And what I'm expecting is we're probably not going to get at a normal TTL level there. So what I mean by that is, typically, you can see this, I'll try and draw this, sorry, no, not the camera over there. What you typically expect, so I can get this on the screen, is sort of rising leading edges fairly square like that. You're looking at sort of that sort of type signal where you got your logic highs, and I forget what the logic high level is. In my mind it's like +5. It's not though. It ends up something like 2 or 3 volts or something. I think I don't know. I need someone who knows a bit more to be able to correct me. I guess I could tell on the scope, but I honestly can't be bothered at this stage. I just want to quickly determine which, is there some strange behaviour going on the data bus there, on the output of those chips, and I suspect there is, at least on one pin. And the reason I'm thinking this is because the consistency of the sound, it's like really, really corrupt. It's constantly corrupt. It's not like 1 or 2 samples. If there was a problem with just one, an area of the one of these VROM sound chips, or it had lost some bits of data, bits of changed state within those, you would expect certain sound samples to be corrupted, and that's the typical problem you get with these kind of cart problems, where certain sounds, certain samples, the introductory splash sound, or it sort of speaks out the name of the game or whatever, or some voiceovers within the game, particular samples, particular sounds within one of these chips. That's the sort of typical problem you get, but with this it's a little bit more than that. And the other thing that's goes hand in hand with that diagnosis, if you like, is the fact there's 2 of these chips. So obviously at some point it's going to be taking samples from one chip. Yeah, that chip might completely be dodgy or whatever, lost, all the samples could have gone corrupted in it, or many of them could have, but then you would expect some really clear samples to come back from the other one at some point, so you'd still expect it to be intermittent, and that is not what's happening here. So like I say, just bearing in mind we should be getting sort of a nice sort of thing like that. And bear in mind also, because this is, my scope's not sort of got a digital storage or anything, it's old analog style. Instead of seeing a nice clean signal like this, it's going to be more, so let's move the camera down again, it's going to be something like more like that, and you're going to see bits of ghosting sort of in various places, where the logic lines are. You might see them sort of shifting around a bit, but effectively it's going to be those 2 lines. Like, you're just going to get 2 lines rather than the whole thing. But it's interesting. The important thing with this, the key, I guess, is understanding you get this logic level here. And what I think we're going to see is on some of the data pins, you're going to get, again, try and keep this on camera, if that's your ground level, you're going to see something like that, very low, instead of up sort of that level there. And what that indicates is probably some sort of pull-up resistor or something internally has failed or something. It might be on one or more of the data pins. So let's give it a go now. I'm just going to connect it to the scope. I'll point you to the scope rather. Can't do all this on one screen unfortunately, because there's just not enough room in here. I'll show you. Right, so I'm connected to, got the ground connected now, and I'm going to start with the bottom of the chip. Now straight away you can see that's not looking right. Let's check the next one, and you can see that's what I would expect. That's like TTL level transition between high and low. Oh, and again, that's another data pin. Look at that. That's not right. Next one. That's okay. Now there's no sound at the moment, so you can see that the pattern's changed. Now watch, that'll kick in when the music starts again in a minute. It's just on a title screen or something to give it a set. Right, that's YM music for the chip, so it's not PCM. There you go. So as PCM kicks in, see the high level is back again, so you've got a good transition there between logic high and logic low, which is what we'd expect, and that's like the 4th or 5th pin along. This is the next pin. Look, that's not correct. So we've got yet another data pin that has got a failed pull-up. Next one's okay. The next one's looking suspicious. That's not right. I think we're getting near the ground now, actually. That one's correct. That looks, I think that's, what's that? That might be the OE pin. Anyway, so I'm going to check the next chip now. Now bear in mind that these are probably connected to the same, well they will be the same data pin, so it's hard to determine from this which of these two chips is faulty, but as I'm going along the pins here you can see you've got like one's okay, one's not, one's okay, that's really strange, that one. That might even be the chip that's faulty because that's given a really unusual. Yeah, this chip is looking very odd. I think this might be the one. I'm going to change this. This is the one I'm going to do first, which is the V4 chip on this board. And just comparison here, I'm going to move all across now to the program ROM chips. So just bear with me a sec. Right, I'm looking at the P2 chip now. I think pinout's exactly the same on these. So you can see I'm on the end pin. That's fine. That's fine. That's fine. See, I'm going all the way along. 1, 2, 3, 4. These are all output pins, and they're looking fine. So, you know, like I say, make it that what you will, but effectively, you know, that was the one I did first, where we had some logic level, you know, some of the transitions there were not right, and pretty much on every other pin, it was bizarre. It's quite a few of them, and they're not in numerical order, so it's not like there's a pattern there. I think just quite a few of them have gone. And then when I did the second one, we got some really unusual. You know, it looked like there was some noise and stuff on there as well. So that chip is acting very strange. I think that could be the one that's causing the problem here. So I'm going to replace this chip first. So let's see how we get on with that. Right, I've replaced the 1 meg chip. The 2 meg chip seems to be okay, as you can hear. Sounding sweet. Get the volume up a bit. Yeah, that sounds fine to me. What is interesting, what I didn't show on camera is I previously had both of the new EEPROMs on there. And with the 1 meg EEPROM, the sound was almost right, but there were a few corruptions just in 1 or 2 tracks, music tracks. And I suspect that the 1 meg EEPROM is either not really a suitable replacement. I think it probably is. It should work, but maybe this is one of the address lines were floating or something, I don't know. bit puzzled. It could also be that the checksum, you know, is not right. It's become corrupt or something, or it was written and not verified, because it was written by a company I ordered it from in China. So I've also ordered a Willems programmer, because I thought I'm fed up with this, you know, not being able to do these 42-pin chips, and I'll probably sell on my other two programmers. There's not any sense in having three Deepon programmers for some of these old retro systems. It's a bit bonkers, really. Everything I can do on the second one I did with everything I can do on the first one I can do with the second one. The second program I got, I could do some of these 16-bit chips, whereas the first one wouldn't. But you know, the Willem should do the whole lot, really, including 42-pin chips. And I think it does 3.3 is it SPI chips as well, so that's pretty useful. Might even be able to somehow use that to do the chips that are on the flash cards, you know, not flash cards, multi-cards. What I'm going to do with this now, that sounds fine in game. I'm going to go into the jukebox, just check a few of the tracks out, because previously these you could tell very audibly, you know, where they were glitching. That sounds fine. Yeah, all the distortions have gone. It seems to be on like guitar sort of. There's something about there. Not sure. I would say it's pretty good now. Strange thing with these, when you get these glitches, sometimes when you're using the jukebox like this, you've got to keep playing the same, restart it, and you'll find it'll distort, whereas sometimes it doesn't. That's why I just keep hitting the button here just to restart this. Yeah, I would say it's case closed on this. This cart is working, I'm sure of it. Anyway, thanks for watching, and I'll see you soon.